Alrighty, welcome to a new chapter for Algebra 1. This is going to be Equations of Linear Functions, Chapter 4. So let's get started. First section, 4-1, Graphing Equations in Slope-Intercept form. So, Slope-Intercept form is probably the most common form of a line. It's one that hopefully you've seen before in pre-algebra. And the definition is the form of a linear equation using the slope and the y-intercept. So, the name of each of these forms, slope-intercept and the one we'll do next, describe what information you need in order to make the equation. So the slope-intercept form uses the slope, which is here, m, and then it uses the intercept, which is b. b could be positive or negative. M could also be positive or negative. And when you plug in, so you'll plug in a number for m and you'll plug in a number for b, but you'll always leave y and x, or it might be f of x instead of y. You'll always leave those as variables. Another option is what happens when the slope is 0. So it's called a constant function, second vocabulary word, is a horizontal line with 0 slope, and it has the equation y equals b. So if m is 0, this whole term, m times x, becomes just 0, and your equation is y equals b. So the key is, if you see something that says y equals b, don't be confused and say, hey, that's not even a line. It is a line, it just has a slope of 0. So when you graph it on your xy axis like this, you'll choose the b value, which is the y-intercept, so maybe that's your b value, and you just draw a flat horizontal line with a height of b. Okay? Moving right along, problem solving tips, 3 of these. The first thing is, to convert a linear equation in slope-intercept form, you solve for y, and then you write it in this equation, in this form. So clear parentheses. All you have to do is distribute anything that's in parentheses and move everything to the right-hand side of the equation except the y variable. So it's really just solving for y, but a lot of times the directions, instead of saying solve for y, they'll say convert this equation into slope-intercept form. Okay, second tip, when you're graphing these kind of slope-intercept lines, the easiest way to start is on the y-intercept. So first, plot the y-intercept. Then you can follow the slope using rise and run to get the next point and the next point and the next point. And once you've made a couple of points, you can draw a line through them. But I really, really highly recommend this. I recommend this form as the #1 form for graphing specifically because of this right here. Plot the y-intercept, that's easy, and follow rise over run to get the future points, which is also easy. And just to remember, y equals b is horizontal line, b is the y-intercept. Okay, let's do just a couple of examples. So convert these into slope-intercept form, then graph. Now remember the directions, convert to slope-intercept form is a fancy way of saying solve for y. So I need to get y by itself, which is this variable. So I need to subtract 4x, minus 4x, minus 4x. Now, a lot of you guys seem to forget this minus sign when you do this, so please remember minus 2x equals negative 4x plus 14. Divide by negative 2, divide by negative 2, x equals, a lot of you guys forget this also, is that this negative 2 is dividing both things in the numerator, so we have to do negative 4 over negative 2, which is 2. Sorry, this right here, I typoed. This negative 2y, this is definitely negative 2y. I apologize for that. And this is definitely a y. So, negative 2 cancels negative 2. We have a y right here. Negative 4 over negative 2 is 2x, so 2x. And then positive 14 over negative 2 is negative 7. So my slope is 2, and my y-intercept is negative 7. So now if I want to graph these, it's pretty easy. My graph won't look very good because I don't actually have a coordinate system, but we go down here to negative 7, and we put a dot. Then we go up 2 over 1. We put another dot. Then we go up 2 over 1. Put another dot, etc. And once you have a couple of these dots, you can draw in your line. And obviously it's to scale, and it will be beautiful if you have graph paper. Second example here, let's solve for y. Convert to slope-intercept form. So you think all I have to do is add 3 to both sides, and you have y by itself, but slope-intercept form doesn't have any parentheses. So actually the best thing to do is to start by distributing. So we have y minus 3 equals negative 5x. Now we're distributing a negative 5 into a negative 9, so that gives us a plus 45. And then now we can cancel out the 3 by adding 3 to both sides. And again, I'll just reiterate the importance of actually showing what step you're doing and showing it on both sides so that it's super obvious when someone's looking back or when you're looking back on your own work at what you did. So 45 plus 3, can't get that wrong, 48. Okay, so our slope is here, -5, and our b value is here, positive 48. This one's going to be quite difficult to graph. So here's our x and y axis. Notice I've drawn them not really to scale because I'm going to start up here at positive 48. And then I'm going to go down 5, which would put me at 43. And over 1, I'll put my dot. Then if I go down 5 again, that puts me at 38. And then over 1. There's my first dot. Notice that on this axis I'm counting by 5s, and on this axis I'm counting by 1s. That's totally okay as long as you label your hash marks with whatever increment you're counting by. So there's my slope, something like that, sloping downward in the negative direction. Okay, so to graph, start with the intercept and then plot rise over run to get the slope. And when solving, solve for y. Alright, that's it for this section.